5G will be unlike any previous generation of mobile service. This report covers aspects of the FCC's report and order for mobile services in the 27 GHz to 40 GHz range that are relevant to 5G. We also look at the significant challenges 5G will face and discuss the related actions being taken by the National Science Foundation to establish a platform for advanced wireless research. Current cellular spectrum is located below 3 GHz. 140 MHz of 700 MHz and 850 MHz spectrum in use today. 345 MHz of AWS and PCS spectrum between 1695 and 2200 MHz. 194 MHz of EBS and BRS spectrum at 2.5 GHz. And of course, 100 MHz of 600 spectrum being auctioned beginning this month. Along with WCS, this is a total of about 800 MHz of spectrum for 2G, 3G, and 4G. 5G will be a long way away from cellular spectrum, located above 27 GHz. 3 blocks have been identified by the FCC for future advanced fixed and mobile services. 850 MHz between 27.5 and 28.35 GHz, and 3 GHz between 37 and 40 GHz. For the 28 GHz band, the FCC will license 2 425 MHz blocks per county. They will, quote, grant mobile operating rights to existing active LMDS licensees, unquote, to enable flexible use for mobile and fixed services. Existing LMDS Channel A1 licensees will receive licenses for both channels. For the 3 GHz in the 37 and 39 GHz band, the FCC will license 12 200 MHz blocks per partial economic area, fractions of economic areas. Coordinated use with federal users will be required in the lowest 3 blocks. The FCC will grant mobile operating rights to existing licensees in the 39 GHz band who hold paired 50 MHz blocks. Repacking of existing licenses to the upper part of the 39 GHz band will be necessary to free contiguous blocks for future licensing in this spectrum. About 65% of the 39 GHz band does not have licenses assigned currently. The 3.85 GHz of millimeter wave spectrum for 5G is almost 5 times as much spectrum as is already licensed for mobile services. This spectrum requires line of sight and provides no in-building penetration. It is not suitable to build a standalone network for mobile applications. As such, the primary value of this spectrum will be to offload traditional cellular networks in highly congested areas, dense urban areas, and other hot zones. This spectrum is likely to have limited use for indoor applications. It is more likely that the 14 GHz of unlicensed spectrum in the 60 GHz band will be the primary millimeter wave band for indoor applications. The use of relatively small licensing areas and 200 MHz channels in the upper bands should promote some competition. However, it is not clear that anyone who does not already have low-band spectrum will be interested in purchasing millimeter wave spectrum. While it is conceivable that wider area networks may be technically feasible to be built using the spectrum, along the lines of meshed Wi-Fi networks of a decade ago, there are many challenges to be overcome. The 2 biggest challenges are a compelling business case and backhaul. A large number of high-capacity, low-cost backhaul links will be required to deliver the gigabit speeds being touted for 5G. Other than a bigger bit pipe, what compelling new service will potential license holders offer? It is fair to say that mobile network operators offered no compelling new services with LTE and so far have not shown much service vision for 5G. So, while the industry is defining great 5G technology, much work remains to be done to define a sustainable business model. Perhaps some of the challenges will be addressed in the public-private partnership announced by the White House. In conjunction with the FCC's report and order, the White House announced that the National Science Foundation will spend $50 million over the next 5 years to design and build 4 city-scale platforms for advanced wireless research. Industry partners are committed to spending $35 million. This initiative is being undertaken to establish proving grounds and benchmarks for the next generation of wireless solutions. The hope is that this government-industry partnership will establish American leadership for 5G, certainly a worthwhile objective.